So, hello everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 3C. Myself, Karthik Bharadwaj, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th February 2024, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you all will enjoy the knowledgeable session and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for their presentation and 2 minutes for question answer round. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected till with us at the last. If you have any query or update, you can write it to me in the chat box. Just before we get started, I would like to introduce you all with the session chair. Today's session chair is Dr. Nilesh J. Modi, Professor and Director, Dr. Baba Saheb Ambedkar Open University, Ahmedabad. Dr. Nilesh Modi is having a rich experience of around 17 years in academics and IT industry. Presently, he is working as Professor and Director, School of Computer Science, Controller of Examination, and NAC Coordinator at Dr. Baba Saheb Ambedkar Open University, Ahmedabad. He's holding expertise on cybersecurity and certification on ethical hacking. He is also serving as a member of Board of Studies and Selection Committee in Gujarat Technological University, Bhavnagar University, along with different universities in the country. Sir, kindly acknowledge our participants.
Thanks, Karthik. Thanks for inviting me. Thank you very much.
Now I would like to extend my gratitude towards the next session chair, Dr. Kanakan Panepong. He is an associate professor at Rajamangla University of Technology, Taiwan, Thailand. Dr. Kanakan received his BBA degree in Information System in 2005 from Rajamangla University of Technology, Thailand, MBA degree Business Administration in 2008, and DBA degree in Business Administration in 2018 from Thailand. He is currently a lecturer at the Faculty of Business Administration and Information Technology, Ramanangala University of Technology, Taiwan, Bangkok, Thailand. Sir, I would like to introduce you with the participants. Kindly acknowledge them.
Yeah, good afternoon in London, and please welcome to our parallel sessions and the water seas. Thank you.
Thank you, sir. Now moving towards the first presentation. For the first presentation, I would like to call Mr. Taimur Muhammad Nazmi for the paper title Color-Based Segmentation of Geometrical Shapes Using Modified PCNN. Sir, you can proceed with your presentation.
Yes, I tried to make sharing. Yes, I can make sharing now. Okay.
Yes, sir, you can share it now.
1 minute, please. Yes, you can see the slides.
Yes, sir, it is visible to us.
Okay. Oh, this is. Okay, Bismillah ar-Rahman ar-Rahim. Good evening, every respected audience. The paper entitled Color-Based Segmentation of Geometric Shape Using the Modified PCNN by Taimur Nazmi and Sulaiman El-Atiyah. The content will talk about the PCNN features and models and how it works, how it used to segment images, and we'll talk about the selected PCN model that was used for image segmentation and the parameter selected parameters also. At the end, we will show the results of segmentation of geometrical shapes and conclusions. As an introduction, it is known that the importance of the image segmentation in many applications with where different methods have been used to achieve this task, including the PCNN. However, this work tried to explore more potentials of using PCNN in segmentation of geometrical shape in image with simple and direct methods. A set of geometrical shape that were isolated, partially overlapped, and connected from a graphical or real image was tested. Here are some drawbacks of used image segmentation methods, which cover edge-based, threshold-based, and region-based, as well as artificial neural network, and even the PCNN. For using PCNN in image segmentation, one can face the challenge of the model numerous parameters that control the output and finding the optimal parameters. One of the advantages of the PCNN structure, it is inspiration of the model from visual cortex of mammal that was developed by Eichhorn in 80s. Here are some developed models that started by ICM and SCM model, and their further developed model. Recently, there was a trend to develop optimizing PCNN models like quasi-continuous, heterogeneous, and continuous coupled neural network. The unique feature of the PCNN include the following features. It is just one layer equal to the size of input image. It needs no training. It is geometrical transformation invariant. It used a limited number of epochs to achieve a specific task. The computational time is low on CPU. It operates on an unsupervised manner. If we take a look to the structure of the PCNN, each neuron corresponding to the single pixel in the input, neurons are connected to their neighbors, forming through the grid. Each neuron has internal state variable represent its activation and linking stress. If we try to zooming in on the individual PCNN neurons, we discover its key components, the receptive field, the linking field, and the dynamic threshold. The respective field defined the area of the input image the neuron responds to. The linking field, and sometimes it's called a modulator, allows interaction with the neighboring neurons. The dynamic threshold, or the pulse generator compartment, serves as gatekeeper, determining when the neuron activates and transmits signals. The firing behavior of the neuron is not only governed by its own input, but also influenced by the output of its neighbors, as shown in this simple figure. How the PCNN take the input image and generate the output image. The PCNN has a great contribution in image processing, such as image fusion, decoding, edge detection, image segmentation, pattern recognition, etc. If we take a look how the PCNN segment the image, the process begins with initialization, setting up the PCNN with the image data. Then dynamic thresholds are updated for each neurons, followed by the firing of neurons that meet the activation criteria. Subsequently, linking weights are adjusted to reflect the evolving network dynamic. This iterative process continues until convergence is achieved, resulting in a binary image where each pixel is assigned to either foreground as an object or background based on its characteristics. This figure shows the simplified used PCNN model. As we can see, there are three main compartments, which is receptive, modulation, and pulse generation. Each neurons receive the output from the neighbor neurons and then try to fire out through the value yig. Of course, this model has a set of mathematical formula that described it. As can we show in this slide, there are a number of parameters. As we our objective to minimize the values of parameters that we need to change during testing. The value of these parameters will given in this slide. The most important parameter that has a great effect, it is the beta, and has a wide range from 0.001 to 10. By testing trial and error, we find that the most effective value for beta was 0.1. Also, the alpha theta was 0.1, VL equal 1, and the WIGKL is a window of size 3 by 3. Of course, in the iteration, number of iteration, we choose it and we try to keep it minimum. All our result, we get the output within in less than 20. Here are some examples of segmentation or arbitrary shape. We can see that the output is not probably segmented according to based on the color of the objects in the images. Here are we can see the effect of iteration on the output from the PCNN. For example, we can see here on the left n equal 2, n equal 5, equal 7, equal 9, equal 14. Each time we run the program for PCNN, we try to find the best iteration number that can be used to get the to isolate a specific object. The challenges in segmentation in geometrical shape, if we use other method, we can, for example, we have to use edge detection algorithm to find the boundary between the shapes and background, then followed by template matching technique to compare predefined shape with the image region, and then using a region-based method where group of pixels with similar characteristics are selected. However, PCNN, by testing, overcome successfully segment these fundamental visual elements in few steps and with low computational time. Now we are going to represent our results. On the left, we can see the number of isolated objects, and we have three iteration, the output from three iteration numbers. Each iteration we can see only one color was selected. On the right hand side, we can see a set of objects, but there are some overlapping between these objects, and the output also can be shown during three different iterations, and we can see that it can segment the overlapped objects successfully. Another more complex image with more color on the left, about 4 color, on the right about 6 color, with different orientation. We can see that the objects are probably segmented based on the color at a specific iteration, even either for on the left hand side or the right hand side. We can see about 5 iterations because there are more numbers of color here, and it
Sorry
can.
to interrupt, sir, but you have 2 minutes to conclude.
Okay, I will go quickly. This is another one on the gray level with circles, small circles, and the white color was successfully segmented. On the right, it colored circuit. Also the white color successfully segmented. This is more complex images with different iteration. We can see how segmentation was done. This is a type of mosaic images with very small objects segmented. Well, also this is another type of mosaic images, also segmented well. This is from real images for building. It can segment white color vehicle, also segment the white vehicles from a set of colored images, colored vehicle segmented white color flexibly. This is the DNA. On the left, we can see that the red color was segmented. On the right, the blue color was successfully segmented. The advantage of this our approach, it is high accuracy, very simple to use, versatility, work both in graphical and real image. As a conclusion, we use the BCNN to segment geometrical shapes. All the parameter of BCNN was fixed except the iteration number. The image used from either graphical or real. We can use a set of images with overlapped or separated or connected, and all give the proper segmentation. Some images has color more than 10 different color and was successfully segmented. This is what the end, and thank you for everybody and your attention. Any question if you like?
Thank you, sir. Sir, do you have any questions? Dr. Kanakan, do you have any questions?
Okay, so please, first let me have some question. Could you please recap what is the contribution to use your research result in applications?
Please again the questions.
So please recap what is the research result can impact or how to implement for the research academic or the contribution in basis.
Of course, this BCNN, as I said before, it is has many contributions in image processing and even segmentation. But to use BCNN specifically for geometrical geometrical shape, it shows unique features that can successfully segment such geometrical objects. Of course, we can imagine this type of processing can be easily implemented in computer vision systems like robots and can be controlled easily. Of course, this type of processing is very does not consume high computational power, and this is important features. As well as it does not depend on optimization of the parameter that normally used in BCNN when applied to in image processing. So this way or this type of processing has many advantages and that can be used in many tasks.
All right. Thanks for your contribution.
Okay.
Thank you, sir. Moving towards the next presentation. For the next presentation, I would like to call Abdul Sattar M. Khidr for the paper title Crosstalk Effect in Amplitude Modulation, the Demand for an Optimized Constellation. Sir, you may proceed with your presentation.
Excuse me, I can't share. Okay. Okay. Okay.
Yes, sir. Now it is visible to us.
Okay. I am Dr. Abdel Sattar Mohammed Khadr from Mosul Technical Institute, Northern Technical University, Mosul, Iraq. My paper is the crosstalk effect in quadrature amplitude modulation, the demand for an optimized constellation. The quadrature amplitude modulation is one of the modulation types for communication. Each combination of bits that build a symbol is mapped into a two-dimensional plane. The two-dimensional plane is composed of in phase or the cosine component and the quadrature phase, which is the sine component with different levels. The order and position of each symbol on the two-dimensional chart is called a constellation or a constellation map. Some of the QAM or quadratic amplitude modulations has two levels. Other are constructed with 4 levels. With 2 levels, the techniques is called the quadrature amplitude modulation. With 4 levels, it is called a QAM 16, since it can have 16 different positions in the two-dimensional plane. Each position represents a symbol of 4 bits. In this paper, we are talking about the QIM 256, which uses 16 levels on both the in phase and quadrature phase. Then 256 symbols is mapped. This is a constellation or binary constellation. You can see the 0 is at the top left position of the constellation. 1 is underneath it, and so on. The most lower left position is for the code or the symbol 15. Then the symbol 16 is next to the 0, to the right of the 0, and so on. This is the binary constellation. There is another type of constellation called gray code constellation, where the 0 is also at the top left of the constellation, but the sequence are different. The sequence of the symbols are differs from the binary constellation. In demodulation process of the QAM, the symbols are extracted and reformed to build the original bit sequence. The channel noise affects these operations and hence degrades the bit rate of the transmission. It is evident that the crosstalk in such channels would affect the performance of in the same way that it is caused by the noise. We made the modeling for the channel for some combination of symbols. The carrier frequency is set to 5 gigahertz. Symbol rate is at 20 mega symbol per second, or 20 megahertz. We use, of course, QAM 256. Sampling rate for the modeling is 1 tera sample per second. This means 200 sample per carrier full wave. The carrier full wave we have 200 samples of sampling rate, of course. 250 carrier full wave will construct one symbol. We can see these different symbols are always sine waves with different amplitude and phase. For example, the red wave is for the symbol 0. It has an amplitude of 15 root 2 units, whatever the unit is, with phase difference is 135 degrees. The symbol 150 is in green and has an amplitude of has an amplitude. Is it seen now? Is the display clear?
Yeah. I'm listening you.
Yeah. The red the red is for symbol 0 and the green is for symbol 150. Here we if the two symbols are transmitted one after the other, then the 0 is at the left, the 150 is at the right. This will cause some jump in between two symbols. The signal time domain appears as follows. As you can see, this would affect the spectrum. The spectrum would make some noise like exceeding the boundary of the channel to adjacent channel. Now results. This was simulated for every combination of successive symbols. The effect of a crosstalk is calculated for noise-free adjustment channels or adjacent channels, assuming there exist 10 adjacent channels with 20 megahertz bandwidth. The effect of the first channel on the next 9 channels is calculated. The results are as follows. You can see this. The assumption here is that the current symbol is 0. Next symbols are 10, 30, 60, 190, 240, as indicated by the colors. You can see the colors at right. The signal to noise ratio for different distances in the constellation diagram between adjacent symbols is seen in this figure. You can see that for most of the cases, as distance increases, the crosstalk level or signal to noise ratio will increase. With some points does not obey this rough law. These are the crosstalk for some different combination of successive symbols. The channel number is at x-axis and the crosstalk signal to noise ratio is at y-axis. We can see here for channel 0, for channel 2, the maximum noise is 12%. The mean is about 2%. For channel 3, the noise is 2% and the mean is 4.4%, and so on, as seen in this figure. Also, we make calculation for the interference between adjacent channels for different successive symbols. The first symbol is seen is at x-axis. The others, the next symbol is at y-axis, and the level the yellow level is noise level, high noise level, whereas the blue is the low noise level. We can see that at the diagonal, this diagonal, there is no noise. The noise is very small, since these are the cases where all the time the signal is sine wave. As a conclusion, the simulation results reveal that the distance between adjacent symbols in the constellation map affects the interference level. The location of 0 and 255 symbols in binary coded constellation are not optimized. These findings can help in improving the performance of digital communication and reducing the impact of crosstalk on multi-channel
Sorry to interrupt,
transmission.
but you have 2 minutes to conclude.
Okay. The impact of the crosstalk on the multi-channel could be reduced. Further research could explore optimization techniques for symbol location, in constellation to minimize cross-channel interference and improve the overall performance of the multi-channel communication. We can have a statistical calculation for which constellation could be optimum for most of the communication. Thank you. And any question?
Any questions, please?
No question from me.
Okay, sir. So we are moving towards the next presentation. For the next presentation, I would like to call Badia Osman Lakas for the paper title Enhancing Diabetic Retinopathy Grading with Advanced Diffusion Models. Ma'am, you can proceed with your presentation.
Okay, let me share my screen first. Okay, so hello everyone. Thank you for the host. My name is Badia Wissam Lakas from the University of Qasdim al-Bahwigla, and I'm here today in order to present our paper entitled by Enhancing Diabetic Retinopathy Grading with Advanced Diffusion Model. In this presentation, we will have an introduction and objectives, diffusion model and its applications, methodology and results, limitation and perspectives. So let's get started. Okay, the main steps that must be taken into consideration for the process of collecting medical images are to obtain an ethical approval, which is mandatory for patient privacy. Also, the data collection equipment, which must be specific, because the organs which are inside the human body cannot be imaged using ordinary cameras. Also, image selection, where we have to select the images that represent the task that we are doing or something, and also to connect images with the ground of truth. This process must be done by expert specialists to ensure the reliability on the data. Okay, so we can notice that these steps are expensive and computationally are expensive and financially expensive. So, and it can be, or it can lead at the end to a data with few number of images. So in order to not repeat this process again, or to not lose much of time and cost, we can use data augmentation techniques. So data augmentation techniques are the solution to increase the number of images in the data. Talking about this, there are several techniques. We can talk about traditional data augmentation, where we can use flipping or rotation or zooming or these techniques. But the main problem of these techniques are they cannot present new features to the data. So we can replace these techniques, or we can generate or augment data sets using generative models as GANs or VIEs or diffusion model. So talking about diffusion model because it is the state of the art of the diffusion models that surpassed GANs, and it was the reason of exploring or of the revolution of these of application of, for example, text to image, where we have seen recently the exploding of this application using several models as DALI and Stable Diffusion, Midjourney. So we've tried it to use text to image. Okay, we've tried to input the prompt of black cat in city made of yarn, and these images was generated using these models. Also, the revolution of application of image variation or image to image, where generating several images, as you can see here, based on an original image. Okay, the idea behind the diffusion model is to destroy or to noise our data or map it to a latent space using Markov chain. The chain is gradually added noise to the data, where every step must depend on the previous step. And so we can see that these data or these images are mapped to a latent variable. And this process will end with a data with pure noise. Yes, pure noisy data. Okay. So the idea of the diffusion model is to train network that can reverse the forward process by starting from the pure noise data that was gotten in the forward process, and to train a network that learned the recovering of the previous process. Okay, this network will predict the mean and variance and to be fit to normal distribution in order to move from the pure noise to original data. Talking about some applications of the diffusion model in the medical field, we can see image generation and synthesis, or anomaly detection, or data augmentation. So specifically, or focusing on the task of data augmentation, we can see these two works where they have used text prompts and images in order to generate a new image that are used to train models. The process or the idea of using text prompts can be exhausted while dealing with medical images, because we have to set a specific or exact description in order to describe this medical information. So our objective is to use image-guided diffusion model instead, while to copy the stylistic and semantic information in the model, and to generate new images that can be used as data augmentation to train a model for diabetic retinopathy grading. Okay, so our methodology, or we have two steps where we employ two different data augmentation technique. The first one is traditional data augmentation, and the second is to generate data from diffusion model. And then we have to train two classifiers based on the data augmented using these two techniques. Okay, so the first data augmentation is traditional, as I've mentioned before, where we use horizontal and vertical flip, and we increased brightness, and these are some samples of traditional data augmentation. For the diffusion model, for data augmentation, we have used the DALI 2 API, where we guided the generated images with the image from our data set. And these are some samples from the output of the images that was generated using diffusion model. Okay, so for the classifiers, we have two classifiers. The first one is a proposed CNN, where we have 3 convolutional layers. These layers, every layer is followed by batch normalization and activation function of ReLU and max pooling. After the convolution, we have 4 fully connected layers with ReLU activation and robot to avoid the overfitting. The second classifier is ResNet, where we replace the last fully connected layer with 2 fully connected layers, and we have an activation function of ReLU between. Okay, so these are the results that was obtained after the training of this model using both traditional and diffusion model. For fair comparison, we have trained this model using same activation function and we have trained these models using same learning rate and same optimizers with the same initialization, and the number of images in both training sets that was augmented using traditional data are the same number of images of the training set that was augmented using diffusion model. So we can notice that the accuracy or the superior performance of the model is when it is trained using images or training set that was augmented using diffusion model. Also, these are plots that represent the behavior of accuracy during the training, where the y-axis is for the accuracy and x-axis is for the epochs. So if you can see that the red lines are for the training and the green line is for the validation, which is the test here, we can see that the models show an overfitting performance when they were training using traditional data augmentation, and was not overfitted using when they were training using diffusion model. Yes, that's it. So as a conclusion, we can conclude that we can use diffusion model as data augmentation to reduce the overfitting and to improve the generalization performance of the models. Also, diffusion model, when they are used as data augmentation technique, they are potential to make the prediction and the decision more accurate and more reliable. So as limitations, we can see that 53% as an accuracy cannot be reliable in the medical field. So it must or it needs to be increased. Also, due to the limit number of images that can be generated using DALL-E 2, so we was limited by a few number of images, which must be increased in the second or in the next works. Also, so for perspectives, we aim to increase the number of images that was generated, and we can compare our let's say we can compare our models or train models and other models using different data augmentation techniques and different generative models. And that's all. So thank you for your attention.
Thank you, ma'am. Sir, do you have any question?
Hello.
Hi.
Hello.
Yes, sir, you are audible to us.
Yeah. My question is that what is the privacy and security measures that you are keeping track for this large number of image data that you are collecting?
Can you please repeat? I didn't hear you clearly.
Yeah, actually, my concern is that you are collecting large number of data in the form of images. Okay, so what is the privacy and security have you looked into it for the security and privacy issues of data?
You mean say in the process of collecting medical images?
Yes, yes, yes. Or you
Yes, so
didn't took it into your scope.
yes, but it's like to collect medical images, these steps must be taken into consideration, as we said,
Nini,
because
have you considered that particular aspects in your research?
so the data that was used in our research was not collected by us, but
Okay,
it
okay,
was yes, it was the IDRID data set that was collected by
okay, fine. Thank you,
others.
thank you. That's
Yes,
it from my side.
yes, thank you.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Guan Hongwan for the paper title Predicting Hanoi House Pricing Using Machine Learning. Ma'am, you can proceed with the presentation.
Yes, thank you. Can you hear my voice?
Yes, ma'am, you're audible to us.
Yeah, I'm gonna share my screen.
Yes, ma'am, the screen is visible to us.
Okay. Hello everyone. I am Vân, and I'm gonna be present my paper title is predicting Hanoi house price using machine learning. And Hanoi is Vietnam capital. This paper gonna try cover some basic information, introduction, methodology, experiment and result, explain the experimental result, and the last is conclusion. To first, we go to the introduction section. Mm, my paper is using machine learning to the dataset gathered from the website bất động sản.com, and we are applying for different algorithm to choosing the best effective algorithm for this dataset. After that, we using 3 evaluation metric to measure the model effectiveness and recommend the most suitable algorithm for the dataset. Therefore contributing to a deep understanding of the Hanoi real estimate market. To get more information, we go to the next part is methodology. The first algorithm we use is linear regression. It's a supervised machine learning model that determines the best fit linear line between the independent and dependent variable. And the second method is support vector regression. It's a effective supervised machine learning algorithm, and that finding a hyperplane such as the distance from the hyperplane to the nearest data point is maximum. And with the high dimension, that's use kernel to define the hyperplane. And the third one is decision tree. A tree structure with 3 type of nodes is root node, internal node, and leaf node. You can see more clear in the graph on the right side. And this algorithm involves making adjustment and constructing nodes in such a way that the error for the generate nodes is minimized. And the last is random forest regression. It's a decision tree framework beyond the regression method, and it improves the decision tree architecture by combining 2 techniques in bootstrapping and ensemble learning. So after applying for algorithm, we use 3 evaluation metric to they are root mean square error, mean absolute error, and R square error. Then after training model, we get the result shown in the table to prediction result. In the mean absolutely error, you can see the linear regression method. This is the first. This is the worst model, and three methods are linear regression, support vector regression, and decision tree regression have a little different in the performance, and the random forest regression being superior method. You can see more clear in the graph here. That's so that random forest is the most effective algorithm for my dataset. After we find the most effective algorithm, we applying it for the test set. Here is some example. After we applying it, Y test is a real housing price and Y predict is the model resource. That's table so that the predict and the real value is really close and the bias is small. That's in the accepted value. Then the last is conclusion section. Beyond the data gathered from the website, we developed the helpful model for predicting house price and also present the information on my capital country. The algorithm we use are for algorithm is linear regression, support vector machine, random forest regression, and decision tree. And the result shows that the random forest regression is the most effective algorithm among 4 algorithms in this dataset. That's all my presentation. Thanks for attention.
Okay, thank you for your presentation. I have
Thank you.
a question to argue. I think that the price the pricing for the house in Hanoi is really challenged, and so how many issue to concerns about the precision for your prediction models. What is my questions? Do you apply or you evaluate something like a domain expert to prove your research results?
Can you?
Because the pricing of house is due to the economics in terms of the pricing, there is no one constraint. They have many constraints to predict in your models. I know your models try to adopt like a machine learnings, but I would like to know do you adopt to evaluate your models like a domain expert to prove your result?
Can you repeat your question?
Okay. I try to recommend you.
Yeah.
Okay, I have no question, but I try to recommend you your research results. So you need to prove your result, like adopt the domain expert to evaluate your models, because this is related to the economics dimensions, because you cannot in my mind, so you cannot prove your model like only statistic. with machine learning, because this is due to in terms of economics issue. So that's why you have to adopt the domain expert in your next paper. So that's it. Okay.
Yeah, I get it.
Okay, so
Thank
turn
you.
to the moderator.
Yeah.
Thank you, sir and ma'am. Now moving towards the next presentation. For the next presentation, I would like to call Andrea Plaza for the paper title Predicting Student Success in Higher Education with Social, Economic, and Educational Variables using Machine Learning Techniques. Ma'am, you can proceed with your presentation.
Thank you. And tell me 1 minute.
Yes, ma'am, now you can
Okay.
share it.
Thank you. Okay. I'm going to have the camera off because there are problems with the internet and sometimes the signal is lost. I'm sorry.
It's okay,
Tell me
ma'am.
1 minute. Okay.
Sorry, excuse me, ma'am. So could you share your screen? Oh, all right, perfect. Thanks.
Yeah, thank you. I'm sorry. Yeah. Okay, and first of all, good afternoon, a cordial greeting to everyone. I am a lecturer at the Computer Science Department at the Salesian Technical. I am going to present my research on predicting student success in higher education with social, economic, and education variables using machine learning techniques. Okay, then I would like to begin. I have divided my presentation into 5 sections. There are introductions where I explain the importance of analyzing student success. And the second one is review of matrix factorization techniques. In a very general way, it will be explained what techniques were used. And the third one is methodology. I explain how the data was structured to carry out the respective test. And the next session is results, where I expose the main points of this research. And finally, section 5 is conclusions. Okay, yeah. Student success is a topic of extensive literature given the importance it represents for educational institutions to be able to detect and act preventively on the students who are at risk of not approving or withdrawing for their studies. Specifically, in higher education, student success can be measured by the successful graduation of students, because if a university student fails to approve all the courses, subjects, and internships in their curriculum, they will not be able to access their degree and therefore will not be able to practice as a professional. Academic quality management systems are not a guarantee of education quality because the educational process is very complex and involves processes like enrollment, matriculation, teaching and learning, etc. All higher education institutions at least store academic data, such as information related to students, their grades, subjects taken, professor information, as well as assigned subject and scholarship. Okay, now our study is based on the fact that access to higher education is based on academic merit and other variables such as social and economic aspects, how socioeconomic status and student performance. That is, despite having academic capabilities, many students abandoned or failed their studies. In our case, the Salesian Technical University, UPS, is a private institution, non-profit. The mechanism used by the UPS to serve the least disadvantaged sectors is the allocation of a scholarship to all its students through a system of socioeconomic quintiles.
To carry out the task of classifying the quantile to which a student belongs, UPS collects social and economic data through a document that is filled out by all those students who wish to benefit from the scholarship system. Okay, and so in this slide, I am going to review of matrix factorization techniques. First of all, it's necessary to know the primary concepts that support this research. First, machine learning, ML, this is a subfield of computer science. ML has the ability to learn to handle data more efficiently without being explicitly programmed. So the purpose of ML is to learn from data. ML is based on different algorithms to solve data problems, since there is no algorithm that is better than another, or that is more efficient to solve a problem. The choice of algorithm will depend on the number of variables, the type of problem, the model, etc. The specialized literature classifies machine learning techniques as supervised, semi-supervised, unsupervised, and reinforcement. Okay. Respect supervised learning is based on a set of input data where some are tests and others are trained. The latter data have an output variable that has to be classified. When the label's output is a numerical value, we have a regression problem. And if the label output is a class, we have a classification problem. Our study relies on a classification problem, since we have to predict if a student aims to graduate or not, yes or not labels. Okay, there are a lot of classification learning algorithms, support vector machines, naive-Bayes, k-near neighbors, and artificial neural networks are the main techniques. Okay. First, a neural network is a method of artificial intelligence that teaches computers to process data. It uses nodes or interconnected neurons in a layered structure that resembles the human brain, and intricate facet involves determining an optical network architecture characterized by judicious configuration of layers and nodes. With respect, SVM includes a regularization terms, which turn out to ensure strong theoretical guarantees in terms of generalization error, since they are based on the theory of statistical learning and convex optimization. The next is naive-Bayes. It's a popular classification method that uses Bayes rules and heights or discussion of conditional independence, overfitting, and Bayesian methods. In NB, we form a joint model of observations X and a corresponding class label C using belief network. And the finish is the KNN is an algorithm that relies on do as your neighbor does. The nearest neighbor algorithm is simple and intuitive. It learns about similarities with other examples. The challenges of the KNN algorithm include determining the optimal number of neighbors key for making predictions. Given its memory base, nature is not scalable for large data sets. Okay. So, with respect to the methodology, in our study, for example, the student, we use social, economic, and educational information collected by the information system in accordance with the introduction session. This information is available for 95% of students of Salesian Technical University who filed or the file to benefit from the scholarship system. It's worthwhile to indicate that we use a data set that collects information for 10 years from a sample of 1,000 students, of whom 39% successfully graduate, and the remaining 61 did not complete their studies. Okay, we use randomly, we generate a 5-fold cross-validation. 5-fold cross-validation is an essential strategy for robust model evaluation. The figure explains 5-fold cross-validation where the dataset, where the data set is partitioned into 5 equal parts or folds. In each iteration, the model is trained on 4 folds and evaluated on the remaining one. Repeating this process five times. This ensures that each fold serves as a test set exactly once. Subsequently, the performance metrics obtained in each iteration are averaged to obtain a comprehensive estimate of the model's performance. Okay, it is an example. Now, to compute result, we use quality metric for confused metric to information retrieval. We have defined 2 states: academic success and academic unsuccess. And the relationship of these states will determine if the result corresponds to
Sorry to interrupt,
true
ma'am,
positive.
but you have
Okay.
2 minutes to conclude.
Okay, yeah. True positive or negative. Okay. This slide shows how making the results for precision and recall. Okay. According to the results obtained, SVM and ANN obtain similar results in both precision and recall, while NB and KIN can be considered the classification learning algorithms that provided the least satisfactory results. Okay, so SVM and ANN are the best techniques in precision. Okay, now to finish, this slide presents the conclusions. Okay, in this work, we don't focus on model accuracy because the main purpose of our method is to measure the academic students' success, maximization the true positives and minimizing the false negatives. This means that true positives and false negatives are the core of the study because the students' follow-up is expensive on time and resources. The main weakness of the model, is the impossibility of explaining the predictions. In fact, the model is a black box due to the high dimensionality and the complexity of ANN and SVM models. In this scenario, neighbor and nearest neighbors are models that we can explain their predictions, but the results are poor. Thank you for your time.
So, do you have any questions?
Okay, so what is the data set that you gathering to run the data? So when you get from the data sets.
Sorry, can you write or speak slowly because my internet is bad and I am I don't.
Where?
Here.
Okay. Where is your data set that you gathering from?
Please repeat or write in the chat, please.
Okay. Oh, okay, no problem, no problem. So please proceed to the next presenter, please.
Okay, sir. Moving towards the next presentation. For the next presentation, I would like to call Tyrone Rodrich for the paper title Towards Birds Conversation in Dry Forest Ecosystem Through Audio Recognition via Deep Learning. Sir, you can proceed with your presentation.
Okay, sir. Give me 1 minute, please.
But now you can do it, sir.
Okay, can you see the presentation maybe?
Yes, sir, it is visible to us.
Okay, and my camera is on, right?
Yes, sir.
Okay. Hello, everyone. My name is Tyrone Rodriguez, and it's a full pleasure to be here today. I'll be presenting our research projects toward birds conservation in dry forest ecosystem through audio recognition via deep learning. Okay, we are collaborating with Miguel Realpe, Paolo Piedradita, Adriana Guilindro, and me, Tyrone Rodriguez, and represent our university, SPOL Polytechnic at Guayaquil, Ecuador. Okay, so the birds play a crucial role in the ecosystem. Okay, serving as a natural pollinators, pest controllers, um, indicator of pollution, right? But preserving these species it's vital to prevent negative impacts on our planet. Therefore, our research aims to find a way to preserve these species and provide support to biologists and ornithologists dedicated to their production. Okay. Oh, in Ecuador, avian species is a primary concern as a country hosts one of the world's largest bird diversity with a 1,699 species. However, 300 of theirs are classified as a treated according Ecuador bird red list. So it's a really bad impact. So our investigation focuses on La Prosperina Protective Forest, located in Guayaquil, Ecuador. And this forest is considered a significant green land amidst the urban area, aims to conserve local biodiversity. Within this ecosystem, 2,000 bird species are found, including 13 endangered species. These birds will be dedicated to our study, as will focus on research six of them at the risk of extinction. Okay, so I will continue with the objective, like identify the features avian species in the dry forest ecosystem, obviously using machine learning techniques, develop an advanced color recognition algorithm, create an intuitive interface for the biologists or conservationists, and finally, evaluate the algorithm efficacy in the dry forest ecosystem. Okay, so about the data or the population size, okay, their audios recordings were obtained from the Xenocanto website, totaling around 2,050 audio files. These recordings contain background noise and other sounds, and which were manually cropped to size of 2 seconds per audio, using, obviously, the Edge Impulse platform. This is a free platform. So we got a different size of the audios. So okay, so when we training our model, if some classes have more samples than others, there could be a bias towards those classes with more data. To address this issue, data augmentation techniques were applied. In this case, we got a shifting time. The shifting time involves shifting the temporary position of the audio signals by a small time interval. And the last one is changing pitch. Changing pitch involves the modifying the frequency of the audio signals, effectively altering the pitch of the bird calls in this case. So finally, we got a correct data set, like around of the minimum, like 300, at the max 700. Okay, we got a correct data set. Okay, at the next step is the audio pre-processing. Audio pre-processing it's a critical aspect of our bird species recognition system, ensuring the accurate classification of the bird call from the raw audio recordings. The processing pipeline consists of several essential steps. The first one is a signal noise separation. Raw audio recordings, okay, often contain various background noise such as wind, rustling leaves, and the others ambient sounds. Okay, so we gotta reduce noise function of the noise reduced package. Okay, and the next step is a signal segmentation. Once the burst calls are insulated, the audio stream is segmented into a smaller, more manageable segments. Okay, and the third one is a feature extraction. From each segmented audio clip, we extract a set of relevant features that capture the unique characteristics of the bird calls. These features include modulus frequency, spectral coefficients, spectral contrast, and chroma featured. By extracting these features, we transform the raw audio data into a structure format that is available for input or our machine learning model. Okay. The next step is a normalization. The extracted feature vectors undergo normalization to ensure uniformity and the consistency across different recordings. And the last step is the convolutional network input. The normalized features vectors serve as an input or our convolutional neural network. Okay. And about this architecture, we got a input layer, normalization for convolutional layer with the interlabel poly layers, add a dense layer, dropout, and output layer with the 6 neurons. Why? Because one for each bird species. Okay. So the next PPT, I will talk about our model performance. Our model has achieved a training error very, very down. And with the accuracy, we got a 0.99% around, like the training or the validation 0.95. So it's a good representation, but we can see this classification better in a confusion matrix, showing the distribution of our model prediction for each bird species class. But the most important thing for the biologists or conservationists is the web interface, because so with that we have a developed web interface that allows users to upload audio files and view species predictions along with the illustration and time graph showing in species detection. We got a video or a demo to presenting this process or a step the biologists are. Okay. So about the Boyer-Moyer-Mayotte-Ball algorithm, implemented to handle prediction for 2 seconds segment, choosing the most current prediction for each 8 seconds segment. In situation when our model produces multiple classification for a single audio recorder, we employ this algorithm. This algorithm aggregates the individual predictions generated by the model and select the most frequently occurring class at the final prediction. So in this case, we got samples of 2 seconds and count occurrences at the final prediction, it's a reinforcement parallel. Okay? But the major Boyer algorithm reduces the effect of occasional misclassification by relying on combining insights of multiple predictions. Okay, so by taking into account the agreement among these prediction, we got a definitely and resiliency of our classification system. In this case, we got a difference prediction, so the final prediction could be a anomaly because we got a difference counts of occurrence. Okay, so this is the view about the difference or multiple detection, right? So in this case, we got a parrot and a tinamou. About conclusions, the algorithm made bigger data collection easier by analyzing their sums. This simplified monitoring and improved the quality and quantity of data for the future research and conservation work. And the evaluation of the algorithm showed good results, confirming is the usefulness in a conservation efforts. It's available to a currently recognized species, highlights its potential of bird conservation projects. About the recommendation, expanding the dataset to include recording from various species and acoustic settings is recommended. It will be improve our model ability to adapt and generalize. It's so important in our model, okay? To stay abreast of the environment change, regular evaluation and refinement of the model are recommended. Updating the model with the recent data while maintaining its accuracy and relevance as bird population evolves. And then finally, it's a collaborating with a scientific and the ornithology can provide valuable insights. Sharing findings and the methodologies will collect advanced bird identification and conservation effort. Thank you for listening. This is the team member in this paper research. Thank you for listening. Any questions?
Thank you, sir. Sir, any questions?
No questions from my side.
Okay, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Naomi for the paper title Risk and Safety Based Behavior Adaptation Towards Automated Vehicles, Emerging Advanced Effect, Challenges and Techniques. Ma'am, you can proceed with the presentation. Ma'am, you can proceed with your presentation.
Oh, hello.
Yes, ma'am, you're audible to us.
Oh, okay. Sorry, my apologies. I was having issues with my audio. I think it's like I'm in a different environment or location, so it's messing up my. I don't know. I don't
It's
know.
okay, ma'am. You can proceed with your
Okay.
presentation.
Okay. Sorry. Let me.
Ma'am,
I'm
your slide
gonna
is not
share.
visible to us.
Yeah, I'm sharing now.
Okay, ma'am.
Can you see them now?
Yes, ma'am, it is visible to us now.
Okay. Okay. Good afternoon. So I will give a short presentation on a study that we ran at the Technical University of Munich, where I'm based at the School of Engineering and Design. And this paper is part of a holistic interview study that we did with different industry experts from the automated driving or automated car domain to automated tracking or automated tractors, as well as automated flying or automated planes, including also automated tractors. So the aim was not specifically towards the vehicle type, rather the automation or the user or human factor issues concerning automation within vehicles and how humans misuse or do not misuse, or the type of misuse that we need to design for when we design these automated vehicles. So we were not discriminative in terms of like only automated cars, even though that's my focus in my own research. So as I think I've mentioned, the aim was to also derive or engineer for behavior-based safety strategies, as well as come up with mitigation strategies for avoiding risk-based behavior adaptation of such automated vehicle systems or vehicle automation systems. So we already have a basic understanding on the different types of behavioral safety practices, as well as risk-based behaviors that users tend to partake in when using automated vehicles or being introduced towards automated vehicles. But we are still working towards coming up with interaction design strategies that foster desirable use and also mitigate undesirable use of different automated vehicle systems. This includes level 2 systems towards level 4 systems, which still requires the human driver to be active and to be situationally aware of their environment, as well as in cases where the system may err. As we all know, technology is prone to error at this specific moment. So an overview of what is currently known is that obviously, as I've mentioned, humans are prone to misuse, and humans are prone to use systems also correctly based on the right conditions and the right knowledge foundation. They will be aware of the system's limitations, which will foster them to be situationally aware in order to avoid crashes or collisions with other vehicles, because they are knowledgeable that the system will err, and their situational awareness is active or prominent in those situations. But in situations where they are not fully aware of system limitations, we do have evidence that they will unintentionally misuse the system, which is then prone to them crashing. We've run simulator studies that have indicated that in the right set of conditions, users can either misuse or use the system correctly. This also involves a lot of the situation or the factors of trust towards the system. Is it calibrated towards the system's limitations, or is it not? Which also fosters their disuse or abuse of the system over long-term use. Another component to our research is not only to look at the once-off use of a system and derive interaction design strategies that promote safety and mitigate risk, but to actually look at the prolonged interaction. So we do repeated evaluations and try to track their behavior towards the system, and as a result, model different behavior adaptations, either desirable or undesirable, and then come up with strategies that mitigate and promote those that we want. So that was a basic foundation of what we are working on. So in addition to that, we try to define or describe what is risk in automated driving. As we know, it will be different in other automation systems. So within our own domain of vehicles, we see risk as a combination of factors that induce harmful conditions on road and in traffic situations that also include risk behaviors such as delayed overtaking, especially with L2 systems that still require the human to take over in a predefined time threshold. We recognize other risk behavior as the user being distracted either by their phones or other factors within the vehicle. We recognize risk factors such as low situational awareness due to fatigue, and also stress factors, all kind of like human factor issues within the vehicle that promote risk behaviors within the vehicle. We also understand safety as situations or systems which promote users to avoid risk behaviors and function in a safety-based behavior approach towards our systems, whether it be L2 hands-off or whether it be L3 systems that are soon to be introduced in Germany. So we also recognize risk and safety issues can either be based on physical or cognitive or emotional components. Physical risk factors or safety factors are situations where the user is exposed to physical issues towards maybe, let's say, they come into collision with another vehicle. Those are physical-based risk factors within the human automated vehicle interaction protocol. We have cognitive also issues, as we all know what that means, and also emotional components. I will not go into too much details because I know that there's not a lot of time for me to go into in-depth discussions. Oh, sorry. So what we did was to have an expert interview with different industry experts and try to understand from their perspective what are the different type of risk factors and also safety factors that they've come across. As I've mentioned before, the aim is not to look at either is it a truck or is it a plane or is it a car, but rather to look at the human factor issues when it comes to humans being exposed to different types of automated vehicles and how they come to operate them in a safety-based manner or in a safe-based manner. So after we had the interview with them, we did a comparative study or a comparative analysis as well as a content analysis towards what their perspectives were. And for this section, we derive different types of viewpoints on what are the negative effects of automation when it comes to risk or safety behavior, what are the positive or desirable effects of automation when it comes to risk as well as safety, and what are the challenges that we see for the future matured systems, as well as what type of techniques can we employ to mitigate or promote such behaviors. So the aim was also to look at that.
His slide is stuck.
Oh, sorry. Okay. So what we learned from our interviews, as I was going to say, we then integrated the results irrespective of the domain or the OEM domain. We integrated the results because the aim was to look for human factor issues, rather than look for per sector. We integrated the results and we came, most of them were all in consensus or in agreement that these vehicle automation systems are designed to support users and to also mitigate risk factors or crash factors, even though there's been cases where with Tesla systems that crash with other vehicle highly or level 3 to some degree systems that are still experiencing misuse factors that are leading to crash behavior or collision.
Sorry to interrupt, ma'am, but you have 2 minutes to conclude.
Yeah, okay. We then try to apply human factor-based solutions in which how can we come up with interaction design strategies that calibrate behavior-based adaptations that are aligned to a safety-based culture of vehicle operations. We were in agreement that as much as automated vehicles have the ability to induce efficient behaviors on road and in traffic, they, however, also may induce different aspects of inefficiencies as well as deficient use of such systems on road traffic. The argument is whether the inefficient use of these systems are intended by users or unintended based on their lack of knowledge. We also realize that there is a need to promote knowledge on human automation skillfulness between human users and automation. How can we reskill users to use these systems as they mature, and how can we also allow the automation to promote such an understanding of itself towards the user as they use the system over time. So in conclusion, we are running a long-term user-centered study between humans and automated vehicles that actually tries to predict the effects of the system towards users over prolonged use based on different experience catalogs, as well as look at the challenges of that specific system and different interaction design techniques that we can then employ to redesign the system to promote long-term behavioral safety or adaptation between itself and the user. Yeah, so I think to save time, I will end here, and then I will allow room for any questions towards what we are currently doing here. So thank you.
Thank you, ma'am. Sir, do you have any questions? Okay, sir. Now we are moving towards the closing remark. Let me just share my screen. I sincerely thank our authors for their excellent presentation and contribution in the session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also thank our session chair, Dr. Nilesh Modi, for chairing the session. This is the token of appreciation to the chair on behalf of team ICICT 2024 and Global Knowledge Research Foundation and partners. Sir, kindly acknowledge our participants. Thank you, sir. Now I would like to extend.
Thank you.
Thank you, sir. Now I would like to extend my gratitude towards the next session chair, Dr. Kanakara, for chairing the session. This is the token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Sir, kindly acknowledge our participants.
Okay, so let me have some speak. So I would like to extend my heart gratitude to organizing committee, the sponsor, and especially you, good modulator. And thank you for our speaker and is the author very participant for their invaluable contribution in making this congress and resources success. Your passions, your expertise, and your commitment inspire us all to strive for excellent and push boundary of what is possible. And thank you for your joys, and see you next conference in next year in ICICT 2025. see you next year, and hope you enjoy in your homes, or and happy and spend a good times in London. Thank you so much.
Thank you, sir. Now I request everyone to turn on their cameras for a quick snapshot. I again request everyone to turn on their cameras for a quick snapshot. Thank you, ma'am. Thank you, everyone. Stay safe, stay connected, take care.